All right, let's talk about Amazon DynamoDB. Specifically, we're going to dive into its operational guardrails. These are the crucial and, often invisible rules of the road, the quotas and constraints that can absolutely make or break your application, especially when you start to scale. So let's get into it and master them.
So picture this. It's kind of the developer's worst nightmare, right? Your app is a huge success, traffic is through the roof, and then, bam, it all just grinds to a halt. You're getting throttled, errors are piling up, and suddenly you're scrambling to figure out what's going on. The culprit? More often than not, it's an invisible wall you just crashed into, a DynamoDB service quota.
So how do we avoid this disaster scenario? Well, here's our game plan for today. First, we'll get really clear on the difference between adjustable quotas and those hard constraints. Then we'll look at exactly how you can check your limits. We'll spotlight the key quotas you are most likely to hit, cover the unbreakable rules you have to design for, and then finally, show you how to manage all this for growth.
Okay, let's dive right in. The first and most critical thing to get your head around is that not all limits in DynamoDB are created equal. Nope. They fall into two totally separate categories, the ones you can change and the ones you absolutely can't. And understanding that difference is fundamental to building anything that's going to scale.
The best way to think about it is like this. Quotas are kind of like the credit limit on your credit card. They're these default safety nets that are set for each region. But if you've got a good reason, you can call the bank, or in our case, AWS support, and ask for an increase. Constraints, on the other hand, well, they're like the laws of physics. They are fundamental fixed rules of the system. They cannot be changed. You don't ask to increase gravity, right? You build your rocket to work with it. Same idea here.
So, if these quotas are so darn important, how do you even see them? I mean, you can't manage what you can't measure, right? Luckily, AWS gives us a couple of really straightforward ways to get total visibility into our limits. The easiest way for sure is right there in the AWS Management Console. You just navigate over to the Service Quotas console, and from there, it is super simple. You just select your region, and boom, you get this beautiful dashboard showing you all your DynamoDB quotas, what the defaults are, and even your current utilization. It is your one-stop shop for a quick health check.
And of course, for all of you command line wizards who basically live in the terminal, you can pull the exact same information programmatically. This one simple AWS CLI command will list out all the default service quotas for DynamoDB. It's perfect for scripting, for automation, or just for getting a quick answer without ever having to leave your keyboard.
All right, so now that we know how to see our limits, let's focus on which ones really matter the most. Because while there are a bunch of quotas, there's a handful that are responsible for the vast majority of those painful throttling incidents and growing pains. These are the ones you need to keep on your radar, always.
Okay, the big one. The most critical quota is throughput. That's measured in read and write capacity units. By default, any single table, doesn't matter if it's on demand or provisioned, can handle up to 40,000 units for reads and 40,000 for writes. But here's the really key difference. For provisioned mode, there's also a combined account-level quota of 80,000 units. That means all your provisioned tables in that region, added together, can't go over that limit. On-demand tables don't have this account-level cap, which is a huge reason they're so great for spiky workloads.
Next up, how many tables can you actually create? Well, the default quota for any AWS account is 2,500 tables per region. Now, this is a soft limit, what we call a quota, which means if your application's architecture genuinely needs more, you can go ahead and request an increase.
So, while you can ask for an increase from 2,500 tables, there's a really important scaling strategy you should know about. The official best practice from AWS is that once you start getting close to 10,000 tables, you should really be architecting your solution to use multiple AWS accounts. This helps manage your blast radius and just creates a much cleaner path for massive scale.
Okay, we have covered the flexible rules. Now let's talk about the hard-coded, set-in-stone, unchangeable laws of DynamoDB. These are the constraints. You can't call support to change these. You have to build your data model and your application logic around them from day one. There's no way around them.
The first, and probably the most famous constraint, is the 400 kilobyte item size limit. Now, that's not just your data. That includes all your attribute names and their values. This isn't just some arbitrary number they picked. It's really a design principle. It pushes you to create lean, efficient data models and stops you from trying to use DynamoDB as a blob store, which is what helps keep its performance so incredibly high and consistent.
Now this one is a little subtle, but it is incredibly important. An item collection is just everything that shares a single partition key. For most tables, this doesn't really matter. But if you use a local secondary index or an LSI, the entire collection of items, so that's the base table data plus all the index data, has to fit inside a single 10 gigabyte partition. This is a critical design consideration if you're ever planning to use LSIs.
And here are a few other really important constraints. Let's do a quick fire round. Your partition key value can't be more than 2 kilobytes. Your sort key can't be more than 1 kilobyte. Using transactions, you're limited to 100 items and a total size of 4 megabytes per transaction. And finally, if you love nesting your JSON documents, you can only go 32 levels deep. These are all hard limits you've got to remember when you're building.
So, we know the difference between quotas and constraints, and we know the key ones to watch out for. Let's bring it all home by looking at how you can proactively manage your adjustable quotas to make sure your application can scale smoothly without any interruptions.
The process itself is actually wonderfully simple. Back in that service quotas console, you just find the quota you need to raise, you click Request Quota Increase, you type in your desired new value, and you hit Request. AWS has really made the mechanics of asking for more capacity very straightforward.
But, and this is probably the most critical piece of advice in this entire thing, you must plan ahead. The AWS documentation says it perfectly. Increases aren't granted immediately. A human often has to review them, and it can take a few days for that to be approved and actually take effect. You absolutely cannot wait until your application is on fire to ask for a fire extinguisher.
So the big takeaway here is this: treat your service quotas as a part of your capacity planning. You need to be monitoring your utilization using the Service Quotas console and CloudWatch. And when you see that you're getting to, say, 80% of a limit, that's when you submit the increase request before it ever becomes an emergency. Proactive management is absolutely everything.
And that really just leaves us with one final thought. It's so easy to look at all these numbers and see them as restrictive barriers, right? But what if we just flipped that and looked at them differently? What if we see them as guardrails that actually guide us toward building more scalable, more robust, and just better architected systems right from the beginning? Something to think about. Thanks for joining me.